Namaste students, how are you all? I think you all are enjoying holidays. Yes, enjoy and study well too. In this session, we are going to learn understanding quadrilaterals. Yes, we have seen many figures, those are in the shape of quadrilaterals around us, isn't it? So in the first figure, if you see, a road sign is given which is under the quadrilateral. Yes, the second one, that is a kite that used to play. It is in the shape of a quadrilateral. And the next one, that is our national flag, that is in the shape of a quadrilateral. Yes. So in this lesson, we are going to study the introduction, polygon, classification of polygons, diagonals, regular and irregular polygons, concave and convex quadrilaterals. Yes. Variety of shapes are found in nature. Yes, there are many shapes around us, right? In the figure, you can see there are clouds, ponds, house with door, stars, right? So many other figures are there. Those are in different shape. And we see that some figures are open and some figures are closed, isn't it? Let us learn them. What are simple closed curves? They are shapes closed by line segments or by a curved line. So what are simple closed curves? They are shapes closed by line segments or by a curved line. So in this page you can see triangle. It is made up of line segments. Yes, the quadrilateral. It is also simple closed curve which is made up of line segments. And a circle. It is a simple closed curve which is made up of curved line. Circle is a simple closed curve we used to say, right? So these are the examples of simple closed curves. Now let us learn the types of simple closed curves. There are three types of simple closed curves. Which are those? The first one we'll see. Some simple closed curves are made of line segments only. Those are called as, yes, those are called as polygons. We see many figures, those are made up of only line segments. Which are those? Triangle, square, rectangle, trapezium, all these are what? These are the examples for polygons. In the figure also you can see the first one is a triangle, second one is a quadrilateral, third one is again a quadrilateral, and fourth one it is a pentagon. Yes. What is that second type of simple closed curves? Some simple closed curves are made by curved lines only. Yes, some simple closed curves will be there. Those are made by curved lines only. You can see many figures, right? So circle and ovals, in this figure you can see circle and ovals are some example of such a closed curve. Yes, the first one is a circle, second one is an oval, third one and fourth one are the simple closed curves which are made by only curved lines. And third one, some simple closed curves are made of both line segments and curved lines. Yes, some simple closed curves are made up of both line segments and curved lines. So there are three figures here. If you observe those three figures which are at the bottom, you see that these figures are made up of both line segments and curved lines. Are you understanding? Yes. So now let us go with the next page, that is simple and not simple, that is complex curves. Yes, simple and not simple closed curves. A closed curve which does not cross itself is called a simple closed curve. Yes, a closed curve which does not cross itself is called a simple closed curve. So if you observe the figures given here, you see that there are some figures Yes, these are, some are crossing themselves and some are not crossing themselves. So the curve which crosses itself is not a simple closed curve, and the closed curve which does not cross itself is called a simple closed curve. So now can you name the figures which are complex here? Yes. So if you observe the figures carefully, you see that the figure D and E are complex curves. Yes. So these are not simple closed curves. And except these two, except D and E, all other figures are called as simple closed curves because these does not cross themselves. Yes. Okay. So now let us go with the next one, that is, what are open curves? Yes, we have seen closed curves. Then what are open? Now let us study what are open curves. The shape which is not closed by line segments or a curve is called an open curve. Right? The shape which is not closed by line segments or a curve is called an open curve. So in this figure, if you observe these figures, yes, these figures are not closed. Yes, the first figure, it is not closed by a line segment. The second one should close by a line segment, but it is not closed there. The third one, yes, it is not closed by a curve. Okay, so now let's go with the open curves. What is the meaning of this open curve? The shape which is not closed by line segments or a curve is called an open curve. So in these three figures, if you see them carefully, you see that these figures are not closed. That is, these are open curves, right? Now let us go with the next slide, that is the polygons. Yes? So what is the meaning of these polygons? From where it has come? The origin of word polygon is, it is from Greek polos, that is, polos means much, poloi means many. From Greek it is gonos, is angle, means poloi gonos, that is many angled. Yes, it is collection of joined straight lines or line segments is called a polygon. So polygon is a simple closed figure which is made up of only line segments. So ಯಾವ ಒಂದು ಕ್ಲೋಸ್ಡ್ ಫಿಗರು ಬರೀ ಲೈನ್ ಸೆಗ್ಮೆಂಟ್ಸಿಂದ ಮಾಡಲ್ಪಟ್ಟಿರ್ತದೋ ಅದಕ್ಕೆ ನಾವೇನಂತ ಕರಿತೀವಿ, ಪಾಲಿಗಾನ್ಸ್ ಅಂತ ಕರಿತೀವಿ. ಎಸ್, ಸೊ ದೀಸ್ ಆರ್ ಸಬ್ಸೆಟ್ಸ್ ಆಫ್ closed curves. Yes, because these are closed, right? Because this is a polygon which is made up of only line segments, means it is closed figure. Yes, so here in this figure, if you see, are all these the polygons? Yes, observe the figures carefully. These are made up of only line segments. There are 8 figures, all these are made up of. In the last slide, we have seen what are polygons. Yes, the polygons are made up of only line segments. Okay, so now let us see in this slide which are polygons and which are not polygons. So the first 3 figures, if you observe, these are the curves that are polygons. Okay, so these are the curves that are polygons. And the second 3 figures, these are the curves that are not polygons. Yes, so if you observe the first one, that is crossing itself, but it is not closed. It is made up of only line segments, but it is not closed, right? And it is not a simple closed curve. And the second one, yes, it is not a polygon. And the third one, it is not closed, therefore it is not a polygon. Okay, so the next one, we'll go for the classification of polygons. How the classification of polygons can be done? The classification of polygons is based on the number of sides a polygon has. Yes, so which are those? If you see, the number of sides, yes, or vertices, and the classification and the sample figure is there in the slide. If a figure is having 3 sides or 3 vertices, what it is called? It is called as a, yes, triangle. A polygon which is having 3 sides is called a triangle. Then if it is having 4 sides, then it is called a quadrilateral. So how to define a quadrilateral? A quadrilateral is a polygon, or a polygon which is having 4 sides is called a quadrilateral. If it is having 6 sides, yes, 6 sides, it is called as a hexagon. A polygon which is having 6 sides is called as a hexagon. Yes, so in the table, if you observe the number of sides or vertices and the classification and the sample figure is given. Yes, if it is having 3 sides, triangle, 4 quadrilateral, 5 pentagon, 6 hexagon, 7 heptagon, 8 octagon, 9 nonagon, 10 decagon, and as the number of sides increases, so based on the number of sides, the name of a polygon can be given. So if it is having n number of sides, it is named as n-gon. Okay. Now let us study the diagonals. Yes. What is a diagonal? Do you know? Yes, you know. A diagonal is a line segment connecting two non-consecutive vertices of a polygon. Yes, a diagonal is a line segment connecting two non-consecutive vertices of a polygon. Yes, so here in the figure, if you observe, it is a quadrilateral. Yes, is it a quadrilateral? Yes, it is a quadrilateral because it is having 4 sides. Okay. So here if you observe, the diagonals are shown as a dashed lines. So that is a figure KLMN. KLMN are the vertices. So which are the sides here? KL, LM, MN and NK or KN are the 4 sides of a polygon here. So which are the diagonals here? There it is mentioned. The diagonals are drawn as dashed lines. KM and LN are the diagonals, right? KM is a diagonal, we will agree. Why? Because it is a line segment connecting two non... Yes, here we see that LN is a diagonal because it is connecting two non-consecutive vertices of a polygon. Yes. Now, let us go with the next slide. That is, can you name diagonals, vertices and sides of below figures? Yes, observe the figures. A quadrilateral is given, a rectangle is given and a pentagon is given. Yes, you have to name the diagonals, vertices and sides of the given figures. Okay, this is a work for you. Now, let us go for what are interiors and exteriors. Yes, a figure may be a closed or it may be an open curve. Yes, if it is closed curve, it is bounded, right? Yes, the part inside a boundary is called the interior. Yes, and the space that is outside the boundary is called the exterior part. In the figure 3.2, if you observe, the first one is the interior. The shaded part is the interior, and in the second one, the shaded part is called as the exterior. Yes. Now, let us go with what are convex and concave polygons, right? We know that quadrilateral is a 4-sided closed figure, or it is a polygon that is made up of 4 sides. Yes. So in this figure, if you see, the first are the convex polygons and the second set are the concave polygons. Yes. So what is the difference between convex polygons and concave polygons? If you observe the convex polygons, we see that all the angles of the convex polygons are less than 180 degree. Yes, observe the figures carefully. Yes, a hexagon is there, parallelogram, a rectangle, a trapezium, a hexagon is there, right? So these are called as the convex polygons because all the angles measure less than 180 degree in these polygons, right? Now let us shift to the concave polygons. Yes. Now observe the concave polygons. If you observe one of the angle in all these figures, one of the angle in these polygons is measuring more than 180 degree. Yes. So these are called as the concave polygons. So what do you mean by concave polygons? The polygons in which one angle measures more than 180 degree are called concave polygons. Yes. Now one more thing what we can observe here is in convex polygons we can draw the diagonals inside of a convex polygons. But in concave polygons, can we draw all the diagonals inside a polygon? It is not. So in concave polygons, some diagonals or one diagonal that lies outside the figure. Yes? Are you understanding? Okay. Now let us go with what are regular and irregular polygons. A regular polygon is both equilateral and equiangular. Yes, equilateral means all sides are equal. Equiangular means all angles are equal. All sides and all angles must be equal. Such a figure is called a regular polygon. Yes. Can you give the example? Yes. Are you thinking? Yes. It is a square, an equilateral triangle. Yes. These are all the examples for regular polygons. So in this figure, if you observe the first figure, that is an equilateral triangle. Okay. In which all the three sides are equal and all the three angles are equal. Therefore, it is a regular polygon. In the second figure, if you observe what it is, yes, it is a square. Here, all the sides are equal and all the angles measure 90 degree. Therefore, it is both equilateral and equiangular. Therefore, it is called as a regular polygon. And the third figure, if you see, it is a right angled triangle. Yes, here if you observe the angles, are all the angles measured equal? No, all the angles are not equal. And if you observe the sides, all the sides are not equal. Therefore, it is an irregular polygon. In the fourth figure, what it is? What? Yes, it is a rectangle. Only the opposite sides are equal and parallel. Yes, only the opposite sides are equal and parallel. Yes, therefore all the sides are not equal here, but all the angles are equal. The condition for regular polygon is what? It should be equilateral and equiangular. Therefore, a rectangle is not a regular polygon, it is an irregular polygon. Now let us go for which are regular and which are not regular polygons in this slide. If you observe the first set of figures, these are called as the regular polygons, and the second set, these are polygons that are not regular. Yes? Can you see the difference between the regular polygons and polygons that are not regular? So in the note it is given, use of that sign indicates segments of equal length. Yes, we all know that. So in the first figure, all the sides are equal. Second figure, all the sides are equal and all the angles are equal. Therefore, these two figures are the examples for regular polygons. And in the second set, only two sides are equal, two angles are equal, but all the sides and all angles are not equal. And in the next figure, only the opposite sides are equal and some adjacent sides are equal. Therefore, these are the polygons that are not regular. Okay. Now, let us go with the angle sum property of a quadrilateral. Yes, we all know that the sum of interior angles of a quadrilateral is 360 degrees. We'll start thinking how the sum of interior angles of a quadrilateral is 360 degrees. Yes, let us say it by an activity. Okay. So, ABCD here. ABCD is a quadrilateral. Okay. Now, I want to consider the diagonal AC. Yes, the diagonal AC, it divides the quadrilateral ABCD into two triangles, right? So, ADC is one triangle, ABC is another triangle. We already learned that the sum of the interior angles of a triangle is 180 degree. Yes. Therefore, here how many triangles are there? Here two triangles are there. Which are those? That is ADC and ABC. Yes, there are two triangles. Therefore, the sum of two triangles is what? Sum of two triangles is 360 degree. So triangle ADC and triangle ABC both are making a quadrilateral ABCD. Yes, therefore the sum of angles of a quadrilateral, interior angles of a quadrilateral is 360 degree. Okay, so now let us see what is the sum of exterior angles in a quadrilateral. Yes, the sum of exterior angles in a quadrilateral is also 360 degree. How is it possible? Let us see. So how we are going to get the exterior angle? Yes, we know that when we produce a side of any polygon, we are going to get an exterior angle. Okay. So the sum of exterior angles in a quadrilateral is 360 degree. I am going to say about the sum of the exterior angles of quadrilateral is 360. How it is 360 degree in the next session. Okay. So now let us go with the external angle property. Yes, sum of exterior angles of quadrilaterals. Sum of four exterior angles is always 360 degree. Yes. Now, if we take the interior angles, in this figure, if you observe the second figure, the angles are A, B, C, D. These are the interior angles. One more activity what we can give for interior angle properties. When we take a quadrilateral in which all the four angles are there, whichever quadrilateral you consider, if we cut out all angles A, B, C and D, and if you collect them and make a circle, yes, if you collect them and connect them to get a complete circle, yes, okay. So after making them a circle, you are going to get the complete angle. What is the measure of complete angle? That is 360 degree. Therefore, the sum of angles of a quadrilateral is what? It is 360 degree. Yes. Now, let us go with what is quadrilateral. Till now, we have learnt all this angles and property of a quadrilateral and everything. It is made up of four line segments. It is a polygon. Yes. So, final remarks. What we can give quadrilateral? It is from a late Latin quadrilaterus. Quadri means four, latus or lateral or later. It is side. Yes, the four-sided figure is called as a quadrilateral. Therefore, it has four sides, four vertices and four angles. Segments of quadrilateral intersect at their end points only. Yes, segments of quadrilateral intersect at their end points you observe the figures, the first set is the quadrilaterals and the second set, these are not the quadrilaterals. Yes, because in the second set, the first figure is what? It is having three sides, it is not a quadrilateral. And this down figure that is having more than four sides. And the above figure, it is non-consecutive sides should not intersect. Yes, is it a quadrilateral? It is not a quadrilateral. And the last figure what it is? The quadrilateral is a polygon, but here in the last figure it is not a polygon. Yes, okay. So now in real life we see many examples. Here if you observe the figures, a chessboard is there, it is in the shape of a quadrilateral, and a playing card is there, it is in the shape of a quadrilateral, and a kite and a road sign, yes, which is under a quadrilateral, and the top of a table, yes, the top of a desk, we can see the road which is in the shape of a quadrilateral. Yes, many figures, many examples you will get in the real life. Okay, so the questions for you based on till now what I told. Is rectangle a regular polygon? Yes. Is rectangle a regular polygon? The next one. Is an equilateral triangle a regular polygon? Third one. Is there a triangle that is equilateral but not equiangular? That you have to think. Does exterior have a boundary? Yes, I taught you what is interior and what is exterior. Does exterior have a boundary? Yes, you only have to write. So this is another activity for you people. So what it is? Match the following. Question. A figure may match to more than one type. Yes, some figures are given and type is given. So which type it is? Whether it is simple closed curve or closed curve that is not simple, simple curve that is not closed,